where it's the crater and it's got kind of spots coming down all around it. They're all kind of starting at the same level.
Exactly, exactly. Now, one idea I had about it was that, because of course the idea, that it is true that water cannot be liquid, at that temperature and atmospheric pressure. But if the water has some kind of particle in it, like an antifreeze,
Yeah, exactly.
you see, like some kind of briny solution, and that's one of the ideas I had in my paper, and that's something that was said recently from NASA about the stains, that the water on Mars has some salt in it.
Hmm.
You see, which lowers the freezing temperature, which raises the temperature that we freeze at.
Right.
So I can't remember. Do we have any color pictures of stains?
No, all the ones they were all black and white images.
Yeah. So even now, there's no new color ones.
Yeah, and from what I've seen, it still seems to be kind of a black gray color.
So that leads me to my next question. What do you think of the idea that maybe the possibility that maybe the stains could be some sort of an oil?
Yeah, that's come up. Well, my thought on that is any kind of oil liquid that's viscous like that, the colder it is, the less it's going to
Unless
flow.
it's going to move, yeah.
So it's like, Mars is pretty, so it won't even flow. I mean, that's pretty liquidy, kind of a fluid flow, that's coming out of. One idea that I had, which I think NASA should take a look into, is that if these are water stains, right, and if there are spores on Mars, like fungi, that the spores will land on these water areas and actually start growing, and that's what gives it that color.
Oh yeah, and yeah, like even some of the stains are actually brighter than their surroundings, which
Hmm.
makes it just a little more complicated.
Right.
Any chance that you're rekindling a podcast about Mars?
Mine, it's kind of my idea was to interview people like you're doing, especially like Mars Anomalous, because some of those guys are kind of whacked out, So and to me, I mean, but it'd be entertaining, because it's their point of view,
Yeah.
that they have these ideas about Mars and they're trying to prove it, by over pixelating something or drawing it, it's like, there's a dolphin on Mars, giant dolphins or eagles or whatever.
Yeah, I get a kick out of some of it for sure.
I was at a UFO meetup in Vancouver, and Alfred Weber was there, and he was showing us look, there's an alien there, right? And I'm looking, it's like it's a rock, right? I was like, I just can't see it. I'm trying, but I thought, is this guy like testing us, or it just seems very strange. Like, is this for real? Is he like disinformation agent, or like, does he really think we're gonna just see an alien in that rock? Oh, it was bizarre. I think it was Mars. I'm pretty sure he was.
What are your thoughts on the face, on Richard Hoagland's face on Mars?
Well, here's the thing. I mean, here's what I think. The original Viking image was a very low resolution image, and it showed the face of Mars. It looked like a face. He wrote the book on it, and now it got re-imaged by NASA on a higher resolution, and it just showed it to be more like just rocks. There's no face there.
Yeah.
So now here's the thing. It's like you can't fight the facts, right? You can't stick to your own theory and say, well, NASA messed up that photo. They retouched it. They messed it up. The face is still there. They just kind of, and to me, that can kind of mess up your, like how credible you are. If even given the facts, you're still like putting blinders on and go, no, it's still the original image.
Or they blew it up.
Yeah, they blew it up. Yeah, right. There we go.
Yeah, I like. It was tough to follow when the new pictures came out. It became pretty evident to me anyway. I have the same opinion that the first pictures were great. If that was ever all we ever seen, it'd be obviously it's a face. I can see why he originally would have thought it would, but at some point you've got to cut your losses, I suppose.
Exactly.
But I think he's still now. Is he still saying the face is the face?
Oh yeah.
Yeah, it's just.
Oh, yeah.
But it's hard. I have a hard time imagining how it can go from looking so much like a face to so much like not a face. Like it does. It does seem hard in a way for me to imagine that.
One thing I noticed, though, because I've been the last little while, I've been cruising Google Mars a little bit,
Oh yeah.
and I was actually looking at the face on Mars, and what I noticed right away is it seems more like an island, like an ancient island. And if you look kind of around those areas, there seems like you can almost see ancient coastlines, and you can see little parts, and you can almost see where the sea level used to be.
Hmm.
Yeah.
But I noticed that right away anyway. Personally, I don't know if that's something you found in your vast picture
But,
searching.
well, I'll leave that Sedonia region to Hoagland, you know, because
Yeah.
these cities in there, you know, grids, you know, just tied it all together. So that's Hoagland's thing.
That's probably a pretty smart move.
No,
But
yeah,
what's
was
interesting with the stains is because when I plotted them, not only were they equatorial, but there were clusters of them, two main clusters, and the clusters were 180 degrees apart.
Oh.
You see.
what do you hypothesize could be the cause?
Well, one thing that's something that Hoagland was working on. He called the Mars tidal theory. But what could have happened is that it could have an impact, see, on one end, and then sometimes the impact goes through the planet
It
and
spits out a little bit.
on the other end. So there's some kind of a fracture zone through the planet on both ends.
Yeah, and then on one side they are right next to the crater too, aren't they? The big crater. I
Yeah.
forget the name of it.
Oh, yeah, Hellas Basin, the Hellas crater.
Yeah, there it is. He knows. Of course, he knows.
But also Olympus Mons, you know, all those major volcanoes have a lot of water activity along the flanks, you know, and so that's an interesting correlation there.
Yeah, I really like that one picture of the stains where it almost looks like it's going through it, split up into canals and everything. Like it seems like that one's really hard to dispute.
Oh yeah. One thing that's interesting too is at that time one of my partners was her name was Jill England, and she was a software engineer. And what she did, she actually wrote up this algorithm to search because it's taking a long time to go to each image on each folder, right? So she wrote a program that would search like the corresponding images. Like I'll find the same image. We were trying to find what we were trying to do back in 2001. We're trying to find if these things were ancient or if they were recurring in recent time. And we mean recent, like within a year's time. So what she did, she wrote up this program that was finding, if I find the same image, she would plug in this program and it would find any other image taken at different times of the same area. So she actually found two images of stains. And the one you can see it was like, this big, a little bit bigger. And the other one you can see it was a lot bigger. And this is within a year's time.
Wow.
So, and that's one of the things that came up in this astronomy magazine article. It's like, oh yeah, we found that, we corresponding, images and we can see this. I said, oh, yeah, we did that. Like,
So,
10 years ago, 11 years ago.
yeah.
were you able to calculate a rate? A rate, say, per day or per year? Or
Per season?
Yeah, at that time, we figured it was like maybe like 20 meters over that period of time, like a year's time. But it's pretty significant.
yeah, so you're talking like a few centimeters a day for sure.
Yeah,
An
something.
inch a day, or
Yeah, it's just flowing down.
like.
Yeah, so, yeah.
Did you do like you built the Phobos monolith? You did a little experiment there. Did you do any experiments with dust or anything like that in relation to the stains?
Yeah, what I did was I was trying to see what NASA was talking about with dust lights because they were saying that certain kinds of dust, very fine dust, like talcum powder, or like cornstarch, for example, dust can flow like water, like a liquid, if it's that fine. So I got some cornstarch, and I got some darker stuff, and I could never duplicate that effect of, you hit something and then it exposes a darker layer underneath. I mean, I could not do that.
Yeah, and well, the other thing to me would be when you've got something that's falling at a rate of only 20 meters a year,
Mm-hmm.
you would think a dust slide that is stirring up that much would be moving a lot faster than that.
Yeah, it would be like a catastrophic flow. I mean,
You'd think like 20 meters a
right
second.
there and it's done, right? Yeah, you're not going to see it a year later, kind of slowly going down.
No, yeah, it seems more like a mostly frozen or some sort of slow-moving liquid or water. Or it seems to me pretty relevant that it's probably something to do with water by this point.
Yeah. So now we just need to go there and land and plant a rover right there on the street there and check it out.
I'd be curious to know, like, if you were able to compare elevations of start points. Like, is there
Yeah,
a set water table, so to speak?
right. It's really varied. I mean, they were actually on hillsides or on the inside rim of craters, on the inside rim, like you said before, which kind of gives the idea of a water table at that level because it was consistent around the same depth into the crater around the whole perimeter.
So yeah, I guess they say Mars is no longer volcanically active, but I suppose there could still be enough heat somewhere down there that is driving liquid water to the surface, and it could be just coming out at
Yeah.
such a slow rate that nobody even noticed,
Hmm.
except for you, of course.
Now here's the thing: if they land a rover or something on one of these streaks, and they're looking real close, and they say, "Wow, it is just dust." Okay, good. My bad. This
Yeah.
from my date. I'm not gonna fight them and go,
Yeah.
"You're lying. You're trying to hide the fact." No, if I'm proving wrong, it's fine. All I'm saying is let's take a closer look, and that was
Yeah.
that was the end point in my paper that I presented at the Mars Society convention. Was all I'm saying is take a look.
Well, and if they would have paid attention to that, then they could have went there and paid a closer look. Like, why did they choose where they chose to land?
Yeah, the driest, most desert.
Yeah, it's so weird. Like,
Yeah, well, I think what the problem is like up until the last rover, it was more of they weren't searching for the coolest place to land; they were searching for the safest
easiest.
place to
Yeah,
land.
that's true.
Because again, you got to think of all the shit involved and what it takes, and you need to not aim for the mountains or the.
Yeah, true. Yeah.
Well, let me tell you guys something. This is going to be the first time it's going to be public. Okay.
Oh, here we go.
Okay. Here we go. So when I saw that astronomy magazine article on my stains, and I wrote to the editor, and I didn't even get a response. I said, it kind of pissed me off. I said, I know I'm a lay person. I'm not a scientist. I'm not, tenured professor. But, give me a break. I actually did a lot of research that's pretty valid. Why can I at least something? Oh, this amateur, astronomer found this. So what I decided to do, and I'm still working on it, I'm working on a public space program.
Oh, really?
Run by the people, by the public.
Huh.
Oh.
And what I call it is the Interplanetary Space Program for Humanity, ISP.
Wow.
And so what it would be kind of a crowdsourcing, kind of a group effort, of the lay people working on this.
Yeah.
We will actually fund it ourselves and direct the missions ourselves and have full access to whoever's found.
That's a great idea because
Yeah, I like that.
crowdsourcing is huge nowadays.
Right.
If Richard Greer can get
Stephen
$1
Greer.
million, or Stephen Greer, can get $1 million.
Right.
Well, I think it was about 300,000 maybe, but still.
Yeah. Yeah, so this is an idea. And one of my first missions, actually I wrote a paper on it. It's not public right now, but one of the first missions was to go to Mars and go into one of these skylight caverns. Right? These openings at Mars that open into the ground. And some of the images of them, you can't see the bottom of them. It's totally dark. That's how deep they are.
Really, I've never even heard of those before.
Yeah, if you Google skylight caverns on Mars, you'll see, and they're actually, the first one is actually found by, I think, like a third grader or something, some elementary school kids, they were doing this program of, take a look at these Mars images and see what you can find. And one kid said, what's that little black dot there? And they zoomed into it, and actually it was the discovery of a skylight cavern. So what that is an opening into a lava tube underground.
Ah.
Oh wow, yeah, I'm just looking at it
So
right
so
now.
are you thinking of a disposable probe then, sort of?
Well, it's just a two-part probe. It would be like a rover, and then it will actually detach, and one part of it would rappel down into
Okay.
But the thing is to go down to the bottom of it. Because if there's going to be life on Mars, it's going to be inside the tunnel like that, or away from the radiation, and it might be water down there, be warmer.
I mean, it would be interesting to know like the cost difference between doing that and doing